determine if the series converges or diverges. If it converges, determine its sum. So we have series n from 1 through infinity 1 over n square plus n. Okay, the bottom factors n square plus n factors, because we can factor n out, n plus 1. That means we can rewrite this fraction as a sum of two simpler fractions, partial fraction decomposition. Let's go for that. N square plus n is same as n factor out n plus 1. So this is same as 1 over n plus 1, and when we write in partial fraction decomposition, the same as writing 1 factor n, a over n plus b over n plus 1. Now we determine the values of a and b. Okay, so let's multiply each fraction by the common denominator, which is n plus 1. If we do that, then n plus 1 cancel for the first fraction, so 1 equals, we get n cancel, so a times n plus 1 plus n plus 1 cancel bn, and this is true for all n. Now we take n equals, let's say 0, then this will be 1 equals, this is b times 0, this is 0, and 0 plus 1 is just 1, 1 times a is a, so a equals 1. And we take n equals, let's say negative 1, then this is 1 equals negative 1 plus 1, 0, so b times negative 1, negative b, or 1 equals negative b, multiply both sides by negative, we get b equals negative 1. So this fraction is in fact a over n, that means 1 over n, and b is negative 1 over n plus 1. So this sum can be rewritten as n from 1 through infinity, a over n, a is 1, so 1 over n plus b over n plus 1, and b happens to be negative 1, so negative 1 over n plus 1. And this is a telescoping series because n plus 1. Now in any case we find the nth partial sum, so lowercase n is already used, so I'm using uppercase n, nth partial sum, that's n equals, the very first term would be, take n equals 1 here, n equals 2, n equals 3, all the way to n equals uppercase n. So the first term 1 over 1 minus 1 over 1 plus 1 2, so 1 over 1 minus 1 over 2, 1 over 1 minus, I'm going to write here, minus 1 over 2. So let me erase this. That's the first term, plus second term n equals 2, so 1 over 2 minus 1 over 3, 1 over 2 minus 1 over 3, I'm going to write minus 1 over 3 here, and I can factor minus out, so this becomes plus. Okay, 1/2 minus 1/3 is the second term, third, n equals 3, so 1/3 minus 1, 3 plus 1/4, 1/4, or you can see from here 1 over 1 plus 1 over 2 plus 1 over 3 minus 1 over 4, minus is factored out, so plus, all the way to nth term, n equals uppercase n, so 1 over n plus 1 over n here, and in this case all the way to uppercase n, so 1 over n plus 1. If you want to write the previous term, so 3 4 4 3, 1 less, so this is 1 over n plus 1, 1 less n. Let's simplify this. 1 over 2 minus 1 over 2 cancel, 1 over 3 minus 1 over 3 cancel, 1 over 4 cancel, all the way to plus 1 over n, this negative plus negative 1 over n cancel, only the first term 1 over 1, which is 1, and the very last term, this minus sign, when we distribute minus 1 over n plus 1, these two terms survive. Okay, that was kind of obvious. n plus 1, the gap is 1, that means we are left with very first and very last term. Now we take the limit of this nth partial sum, when n goes to infinity, 1 minus n goes to infinity, 1 over infinity, 0, 1. That means this series converges and the sum is 1. So the series converges and the sum is 1, or the series converges to 1. That's the sum.